Hi guys, today I'm going to explain to you the concept of modular arithmetic. So just get so we're going to talk about modular arithmetic. Now the concept of modular arithmetic is based on a finite set of numbers of integers actually. So basically it's about performing operation on a certain set of numbers. For example, we can perform operation on the set of number that belong to the integer set 2 or 2. In this case, this corresponds to the set that has the two numbers zeros and 1. Now modular arithmetic, of course, it's based on a positive number of integers, so which is in this case, so you can refer to modular arithmetic as there is a number n or m that represent the number of digits or the number of items in the set. So again, so we can say that also n represent the number of items, which is digits in the set. So in this case, if z2, which is two items 0 and 1, if we have z 26, we have the items 0, 1, 2, all the way to 25. So there are 26 different elements. Now, the concept of modular arithmetic is based on finite, as I mentioned, finite set of numbers. So let's say, for the sake of argument, let's take an example of n equal to 4 different numbers, or in other words, we are looking for a set of integers that belong to z4, and of course in this case the set is 0, 1, 2, 3. So think of it this way, that it's a finite set of numbers. We can represent it on a clock shape, so where we have 4 different positions, and only 4 different positions. So the first position is 0, 1, 2, and 3. So in other words, we don't have 5, we don't have 6, we don't have 7, although we can represent them. Okay, so for example, if you have a number that is 5, how do we represent that 5? Of course, 5 doesn't belong to the set of numbers. Hence, we have to I just want to make sure that I'm recording. Yes, which is I am recording. So 5 doesn't belong to the set of numbers. Hence, this is going to we're gonna say that is 5. What is 5 mod based on the modulus 4? So we are looking for that number. So 5 mod 4. So if we try to move in the clock, so we have, this is 0, this is 1, this is 2, this is 3, this is 4. 4 actually is, there's no number called 4. 4 is actually 0. So here it's 4, and this is going to be 5. So actually 5 mod 4 is equivalent to 1. So here in this case we say that 5 and 1 are equivalent or congruent with each other, okay, in or within with respect to the mod 4. So mod 4, it means that we only have 4 digits or 4 numbers in this case. Now of course, if you have another number, let's say another example, if you have 8 mod 4, so obviously in this case, so we start with 0, 1, 2, 3, 4, 5, 6, 7, 8. So actually 8 is or belongs to this or equivalent to 0, and it's also equivalent to 4. So we can say that all these numbers are equivalent with each other. So the answer here is 0. Now the way that we can also understand the mod is basically the remainder. So another way to say that 8 divided by 4 is 2, and basically the remainder is 0. So actually you can say that 4 mod 4 is the remainder portion that we are looking for. So it's the remainder of the division between 8 and 4. Okay, so that's the definition of modular or mod 4. So in this case, we started by talking about modular arithmetic. It's a finite set of integers, and there's operations, which is, of course, the operations are the addition and multiplication that can be invoked on these numbers. So an n represents the number of items in the set. So for example, z2, which is the item of that belongs to that set, which is 0 and 1. 26, we have the items 0 until 25, and mod is when the set is equal to 4, or n is equal to 4, so the set of integers is 0, 1, 2, and 3. And we modeled the mod or the modular based on the finite set, and we represented for example, mod 4, which is there are 4 numbers, so 0, 1, 2, 3, as a clock, it's digital clock, and that is rotating or overlapping, okay, and the numbers are overlapping because we don't have numbers that is 4 is actually 0, 5 is actually 1, 6 is actually 2, and so on. And then we looked at it, we say that okay, fine, the modular is basically the remainder of the division. So 8 mod 4, when we divide 8 by 4, and the result is 2, and the remainder is 0. So another way to look at it is that the modular represent the remainder. That's why when we looked at those numbers, which is 0, 1, 4, and 8, as appears here, 0, 1, 4, 8. All these numbers, they have something common between them, and that's why we call them equivalent or congruence. So they are equivalent to each other in the mod 4 type of numbers. Now, of course, you know the 1, 5, also 9, 13, and so on. All these are equivalent with each other. You can pay attention to those number. You can think of this as different dimension or different trays. All right. So we have here 3, then we have also 7, and we have 11. Then here we have 2, then we have 6, we have 10. So all these different numbers, they actually represent all the different sets that when we combine them together, they will give us all the different range of number that is from minus, for example, n all the way to positive n. So this set so also we can look at it from the numbering system: 0, 1, 2, 3. So here minus 1, minus 2. So basically, if we're talking about mod 4, 0, we have 0. So we always have 0, 1, 2, 3. Then for 4, it goes back to 0, because you know this is the numbers. We run out of the numbers. Then 0, 1, 2, and 3. Here the same thing. So this is here 3. This is 2. Minus 3 is 1. And minus 4 is 0. So it is the sequence of numbers. This is how we look at it. Thank you, and I'm gonna stop the video right now.